characteristics of rational functions. So polynomial functions, which we talked about in the first half of chapter 4, are all nice functions. They're smooth and continuous, meaning I can draw them with single draw of my pen. Rational functions where I divide two polynomials, that's not the case. All right, rational functions have discontinuity for any value where I get division by 0. There's a break in my function when I have division by 0. And so when we did the domain earlier in the previous video, all of those values that were not in the domain, in my graph there should be breaks. Right? And there are two types of breaks. There's either a asymptotic break or there's a single hole in the function. And it's still a break though because the function doesn't exist at that single moment. Right, so there's two cases. We're going to focus right now on the asymptotic case, but then we will get back to the hole in the function case. All right, so we will have asymptotes. Actually, there'll be 3 different types of asymptotes with rational functions we'll get to. The first type, though, are the cases that land in the break of my function, which causes me to have dividing by 0 where the function doesn't exist. And in those cases, we never ever touch those asymptotes. All right, so these asymptotes. So we're going to look at a graph. We're going to kind of analyze this behavior. So a rational function, which I've factored the denominator because it's just easier to talk about, find the division by 0 when it's factored. All right, so here's my rational function. I factored the denominator into x minus 2, x plus 3, so it's a quadratic. What x values produce continuity? These are the values not in the domain. All right, well, what values are not in the domain? I have discontinuities. When the domain gives me out zeros, well, at 2, right, 2 will give me a 0, and at negative 3. Those are the values not in the domain, and so in my graph, those should be values where I've got a break in my function, a discontinuity in my function. Alright, so not in the domain, break, discontinuity. Now x and y intercepts, we should be able to find in rational functions. So x-intercept are when the r of x equals 0, and what it comes down to is the numerator is the only place I can have a 0. I can't divide by 0. So you set the numerator equal to 0. Right? And then you have to check your answer. Always check that it's in the domain. Right? Always check every answer that is in the domain. You can only have answers that work in my function. And so in this particular function, the only value that's in the numerator is 0. And so the x-intercept, the only x-intercept possible is 0. So 0, 0 is my x-intercept. All right, y-intercept. Is the easier case. That's when x equals 0, so we see if we have a 0. And in this case, it's going to give me 0. And so 0, 0. So my x-intercept and y-intercept are the same. Whenever it crosses the origin is always both an x and a y-intercept, right? Because that's where my x-intercept hits my y-intercept. All right, I'm going to graph the function. All right, so I'm going to go to my graphing calculator and I'm going to graph the function. So I'm going to clear out whatever I have in there. Be careful when you graph these. And so up top is x. Divide by, put parentheses around what you're dividing by. So there's going to be 3 sets of parentheses. There's the big set with what I'm dividing by, and then the little set x minus 2 times x plus 3. If you don't do that, what will happen, if you don't put the parentheses around the denominator, it'll take x divided by 1 minus 2 and then multiply by x plus 3. It won't follow order of operations. So you need to make sure you put a big set of parentheses around the denominator so that you can make sure you have the right graph. And then I'm going to go to zoom standard. So 6 on a standard window. All right, so there's my graph. All right, so again, my graph of my function. I know it's going to go through 0, 0, and then if you look at it, there are breaks. So if you look here, there's a break here, and there's a break there. So there's a break at 2, and there's a break at negative 3. I know there's a break at 2, and there's a break at negative 3. And then the shape of the graph, it comes down like this, crosses at the origin, and goes down like that. It's sort of an S shape. And then on this side of 2, it has this shape. And on this side of 3, it has that shape. Right, that's what your graphing calculator is showing. If I go back to my picture, right, that's the graphing calculator. So what's happening, there's a bunch of stuff going on. What's happening as x goes to infinity and as x goes to negative? So that's going off at the tails here. What's happening as my x values, right, these are my x values, go to infinity, as my x values shoot off to negative infinity. What's my function doing? What are the y values doing? Well, the y values in this case are approaching my axes, right? The y values are coming down, and actually if you go back and look at the graph, you can barely distinguish the axes at the tails, at the edge of the graph. You can barely distinguish the graph from the x-axis. And so it's approaching the x-axis, which is the value y equals 0. And so the y values approach 0 on both tails. The y values approach 0 on both of those. All right, so at the ends, my y value is approaching the x-axis, which is the line y equals 0. All right, what's happening during my break? So remember, I've got one break at negative 2, and we want to know what's happening to the right and the left. And so negative 2 is here. So, or not negative 2, positive 2. Positive 2 is here. This is my positive 2. What's happening to the left of 2 and the right of 2? And this actually has to do, if you ever go in to take calculus, this actually has to do with, there's limits. These are special limits. Not that we're doing limits in this class. But what happens, there's a break at 2. My function breaks, right? Doesn't exist at 2. I have division by 0. But something interesting is happening on both sides of my break. On the left side of my break, so the left side is this over here, it's shooting off to negative infinity. So as x approaches 2 from the left, my function, my y values are getting infinitely small. On the right side, so x approaches 2, but now I'm on the right side of 2, my y values are shooting off to positive infinity, right? The right side, it's getting bigger and bigger and bigger and bigger and bigger, and it does. It goes infinite. It gets closer and closer and closer to 2, never gets to 2, but as it's getting closer and closer to 2, my function is shooting off to infinity on the right side, shooting off to negative infinity on the left side. All right, well, let's look at the other break and see what's happening at the other break. All right, so at negative 3, what's happening to the left and the right? So I'm going to go back up to my graph. So here's my negative 3, right? There's a break at negative 3. My function breaks. And you'll see something similar is happening here at this break 3. This would be the left, and this would be the right. On the left, I'm shooting off to negative infinity, just like on the other one, and on the right I'm shooting off to positive infinity, and so something very similar happens here. As x approaches negative 3 from the left, my function shoots off to negative infinity, gets smaller and smaller. As my function approaches negative 3 from the right, my function approaches positive infinity, and so at that break, it doesn't exist at negative 3. Right? But it gets closer and closer and closer. As I get closer and closer and closer to negative 3, on the right side, my function shoots off to infinity. On the left side, my function shoots off to negative infinity. And that's significant. So like I said, if you go on to calculus, what you'll do in calculus is those will be very special type of limits to infinity. We don't do that. We're just talking about the behavior. Whenever we have a break in the function, this is the typical behavior. All right, so we're going to get into asymptotes and the end behavior. That'll be my next video.